On the behavior of artificial neural networks parameters. I am Cagatay and my mentor name is Serdar Demir. We are both from University of Muğla City Koçman, from City of Muğla, Turkey. And welcome everyone who is gonna listen my presentation. Contents. We will start with artificial neural networks and then the basic elements of artificial neural networks and go into deep the specific elements. And then I will show you the results from different applications I've done in past, and then we will finish with the conclusions. Artificial neural networks is an improved analysis approach by mimicking biological neural networks in living organisms. In other words, ANN consists of algorithms that mimic the features of brain of human being. These features are generating new knowledge and exploring by learning. In spite of that, there are great differences between artificial neural networks and biological neural networks, both in architecture and in ability, by Zurada, 1992. ANN is form of a mathematical model and are known as a general function approximators by Zhang et al. 1998. The nature of ANN allows to be schemed by its architecture in the form of visual presentation. We can see the different types of architectures that defines the working principles of each artificial neural networks, such as single-layer perceptron, radial basis network, and multi-layer perceptron, recurrent neural networks, and LSTM recurrent neural networks, Hopfield network, Boltzmann machines, and such. Learning ability is the most important characteristic of ANN, which allows learning from examples, experiences, patterns, functional relation mapping, and so on. The idea of using artificial neural networks for forecasting is not new. Actually, the first application dates back to 1964, who used Widrow's adaptive linear network to weather forecasting. Learning algorithms make this process occurs, and widely preferred popular algorithm is called backpropagation, which was introduced by Verbos in 1974. In many studies, it's pointed out that the discouragement in this field has been made after studies of Mies and Rogov in 1983, who stated that simple random walk is the best economic model for exchange rates. But one of the first important study of artificial neural network by Lapidus and Farber in 1987 and 1988, they designed feed-forward neural network for time series forecasting. After this study, they proved the strength of the ANN for nonlinear learning ability with backpropagation, learning algorithm, and nonlinear activation functions. As it can be seen from the graphic on the right, the evaluation of artificial neural networks started so early, along with other soft computing and heuristic approaches, and with the backpropagation algorithm, artificial neural networks boomed after mid-80s. And it can be seen if we go into deep look to the graphic, the conventional artificial intelligence start with the cybernetics and way down to neurophasm modeling and genetic programming in 1990s. And even today, the neural networks emerged to deep neural networks, which is a way better approach for forecasting tasks. All right, now we will talk about the basic elements of artificial neural networks, which are given below. They are architecture, learning algorithms, activation functions, and performance measures. And in this study, we will focus on the feed-forward neural networks, which is widely preferred by practitioners and implementers and researchers around the world. And for brief information, the feed-forward neural networks is a type of a multi-layer perceptron which has an interconnection between all neurons in the network. And unlike different types of multi-layer perceptrons, such as recurrent networks, feed-forward neural networks has no loops or circles within the architecture, and signal flows through the input layer to the output layer in only one direction. Learning algorithms. Learning process can be described as finding the best weights between the layers, and We can give an example of eight different learning algorithms. They are such as Leeuwenberg-Marquardt backpropagation and Quasi-Newton and scaled conjugate gradient, a conjugate gradient with Powell and Bill restarts, Fletcher and Powell conjugate gradient, Pollack-Ribiera conjugate gradient, one step second, and variable learning rate backpropagation. Learning ability from a source of knowledge is one of the most important characteristics of artificial neural networks. And recent studies about artificial neural networks have shown that one of the most common learning algorithms is Leeuwenberg-Marquardt backpropagation. Therefore, we will focus mainly on Leeuwenberg-Marquardt backpropagation algorithm as learning algorithm in this. Activation functions enable mapping nonlinear relationships between input and target values. The performance of neural networks depends on the suitable choice of activation functions. In general, the activation functions provides a measure of a nonlinearity, so it plays important role in an artificial neural network modeling. And we can see the most common activation functions as logistic sigmoid and tangent sigmoid function. And there are many different types of performance measures can be found in the literature too. The importance of performance measures is about selection of the model. So every different performance measures have different behaviors and different way to calculate error. So we can see a couple of performance measures can be found in literature, such as mean absolute error, and root mean square error, and percentage errors, and relative errors, and such. And there are different kind of performance measures can be found in literature, which has a combination of different performance measures together to formalize a better way to calculate errors. We can give an example like a weighted information criteria, which has a Akaike and Schwarz information criteria, a root mean square error, mean absolute percentage error, direction accuracy, and modified direction accuracy. And the coefficients are the sum of coefficients are equal to 1, as it can be seen from the formula. And the other one is extended weighted performance criteria, which has 19 different performance measures gathered together from the literature for better calculation of error. All right, now we will talk about more specific elements of artificial neural networks, such as analyzing data, the input selection, data division, epoch number, layer number, neuron number, and standardization of the data. Analyzing the data should be the most important and the first part of modeling with artificial neural networks. Specifications of the data must be considered carefully in order to tune parameters of artificial neural networks. If data isn't understood well, it will affect the input selection and tuning other parameters of artificial neural networks, which drives the process to bad results. Different kind of data characteristics can be found in real life, and on the right side can be seen some examples of data shapes and as financials, exponential, seasonal, and such. Input selection is another important step that directly affects the outputs, therefore results and performance. Input selection strategy must be considered carefully in according to satisfy the output demands by the implementer. In most cases, input layer neurons consist of vectors as a partition of data, such as lag vectors if data is time series, or dependent variables if data is multivariate, or both. As stated in Zhang et al. In 1998, training and test sets are required to build the artificial neural network model. Training set is for model development and test set is for evaluation. Another division choice can be made to avoid overfitting problem or to add stopping point for training process. And it can be called validation set division. The question about data division is the ratios. There's no constant ratios for each sets, and it differs according to the problem and actual experience of implementer. Common usage of ratios are from 10% to 30% for test set and 90% to 70% for training sets, respectively, by literature. Epoch number is a stopping parameter which is needed to end an iteration of artificial neural networks in the modeling process. The training process can be stopped or end by reaching desired error, validation set, and the epoch number. Usually, epoch number is the primal element to affect time. If epoch number is being set higher than enough, that will end up more time it takes to get results. Oppositely, if epoch number is being set less than enough, that will end up missing better results in shorter time than the process needs. This confusion can be accomplished by creating memory metrics from previous works. Experience is the key to determine best epoch number by using a memory matrix. As it can be seen from example above, epoch number was set as 1000 for 144 possible architecture, and only the 62% of process ended by epoch number. Therefore, for this data, epoch number must be set higher than 1000. Layer number for all artificial neural network architectures are constant for input and output layer as 1. However, for hidden layer number can be varied from 1 to any desired value. Most cases, only one hidden layer is enough for any artificial neural networks to make it a universal approximator. But for more complex data and situations, artificial neural networks can consist two or more hidden layers for handling complexity. Having many hidden layers in artificial neural network is called deep neural networks in literature and considered as more detailed approach. And on the right side, we can see the architecture and the visual presentation of artificial neural network with more than one hidden layer. Neural numbers in each layer of artificial neural network should be set according to the data and the strategy of the implementer. Determining the number of neurons in the input layer can be equal to the lagged vector number or dependent variable number of data. In many cases, determining the number of neurons in output layer usually will be the most easy part because independent variable of the data represents the neural numbers in output layer. Determining the neural numbers in hidden layers is hard part of this process because it represents the complexity of the system, and most common way to determine the number of neuron is a trial method. Usually implementers choose to try number from 1 to any value which gives least error at the end. Standardization of data can be made between any lower and upper bound if better calculation time needed. Also, it can be called as transformation of data with specific functions such as logarithm, square root, and etc. Although standardization could make better calculation time, it can lead several problems afterwards, like division by zero in case of performance measure calculations if it's made before inverse transformation of data. A critical issue is the manipulation could be done about data. This can result more easier modeling with very less error, but manipulations leads extinguishing the uncertainty from data and changing the true characteristics. And on the right side, we can see a formula which standard any desired data for 0.5 to 1. And results from different applications, and we can see here the results of different combinations of learning algorithms, activation functions, and different performance measures for the same data, and results can be seen detailed from the chart. In this specific application, we were focused on the time links between different parameter combinations, and it can be seen from the chart. The process can took only 2.3 minutes up to 64 minutes to end. And in this application, we were focused on the correlations and the This application has two hidden layer feed-forward neural network, and the R propositions of performance measures as extended weighted performance criteria has calculated and choose the model with 100% of the correlation between output and test sets. And in this specific application, we focused on the forecasts from different type of simulated data and the exchange rate data, and what step ahead forecasts with the actual values can be seen from the chart. And the visual performance of predictions for the test sets and actual outputs of the model can be seen from the graphics also. And here we can see the different data for the visual performance. Conclusions. In this study, we focused on the details of artificial neural network and the behaviors of parameters that affects the results, less or more. The implementers, practitioners, researchers, and anyone curious about working with artificial neural networks can use this guide for brief information before start. Potentials of ANN grows exponentially day by day, and new methods are emerging so fast. Experience-based models such as artificial neural networks can give better or worse results according to the implementers. So people who is working with ANN must be focused with their strategies and they need great focus on their data. Thank you so much for participating, and in case of communication needs, you can see our email address below. And thank you all for listening our presentation. And these are the references that we have used for our study.